Greetings, welcome. Let's have a further look at rational functions with slanted asymptotes or oblique asymptotes. Alright. In the previous video we sketched this one. Now we're gonna sketch the second one. Just a rough sketch. Okay, so let's get started. Okay, let's see if we can factorize the numerator. X squared minus x minus 2. So write my brackets and the values of x, and then I look at the numerator. Which two numbers, if I add them I get minus 1, and if I multiply them I get minus 2. So okay, minus 2 plus 1. Minus 2 plus 1 gives me minus 1. Minus 2 plus minus 2 multiplied by 1 gives me minus 2. So this is okay. X minus 1. So there is no factoring anything out here. Nothing cancels out. That's okay. Okay, cool. So let's get sketching. Before we sketch, as usual, let's find the location of our vertical asymptotes, and that is found by finding the zeros of the denominator, and the zeros are found by setting the denominator equals to 0, and this gives me x as one of the location, or as the only location of the vertical asymptote. Do we have a horizontal asymptote? No horizontal asymptote. Reason being, the numerator is of a degree higher than the denominator, so no horizontal asymptote. So if there's no horizontal asymptote, it means we have slanted asymptote. So we need to find the equation of the slanted asymptote. To do that, we perform long division. Okay, x minus 1, x squared minus x minus 2. Long division, x squared divided by x, that is x multiplied by x multiplied by x gives me x squared. X multiplied by minus 1 gives me minus x. Okay, all this subtract from that one. Okay, cool. X squared minus x squared, x squared minus x squared, that is 0, minus x minus minus, so that is minus x plus x, that is 0 x. Okay, interesting. Alright, cool. Bring down this one, minus 2. 0x divided by 1x, that is plus 0. 0 multiplied by 0, that is 0 x. So 0 multiplied by minus 1, that is 0. Okay, 0 minus 0, that is 0, minus 2 minus 0, that is minus 2. Okay. Okay, cool. So we see from here the remainder is minus 2. Therefore we can rewrite our function in terms of the answers we got. G of x is equals to x plus minus 2 over x minus 1, which is the same thing as x minus 2 over x minus 1. Cool. So the answer of from a long division, this linear equation here, is the equation of our oblique asymptote or slant asymptote. So the slant asymptote is located at y is equals to x. Just this one here. Interesting. This is very nice. So from here we can already see when x-intercept, looking at the x-intercept for the linear equation, when x is 0, y is 0. That's the x-intercept. The y-intercept of the linear equation, same story. When y is 0, x is 0. Let's find the x-intercept of the rational function. X-intercept when y is 0. 0 is equals to x minus 2 by x minus 1. Okay, maybe I should use the unfactored one or unsimplified one version. Use this one. Okay, so this will be x squared minus x minus 2, x minus 1 all follows multiplied by 0, which is 0. So okay, so the zeros of this guy, that's x minus 2, x plus 1 equals to 0. Therefore 2x intercept, 1 at x is equals to 2 and 1 at x is equals to minus 1. 2 and 1 equals minus 1, 0. What about the y-intercept? As for the y-intercept, x, we substitute or plug in x equals to 0 in the equation. G of x equals to 0 squared minus 0 minus 2 divided by 0 minus 1. Therefore we have minus 2 over minus 1, which is equals to 2. So when x is 0, y-intercept, when x is 0, y is 2. Cool. Nice. Let's plot our graph. our Cartesian coordinates or plan. What do we know? We know the location of our vertical asymptote is at 1. Is at 1. There is no horizontal asymptotes. We have a vertical asymptote, which is at y is equals to what? To x. So to pass through the region like that. Okay, so y is equals to x. X-intercept, we have 1 and 2 and -1. 2 and -1. Okay, 1 and 2, 2 and 1 and -1. Alright. Already this tells me the graph is in this region. So our graph will approach the asymptotes but never touches the asymptotes as the asymptote approaches infinity. Okay. What is this here? What is this point here? I can find this point. I know x is 1, so y must also be 1. Just equating it in that equation. When x is 1, y is also 1. Okay. So I know my graph crosses here, so it cannot cross the asymptotes. So my graph will look something like this. It will approach the asymptote y is equals to x as the asymptote approaches infinity, and it will also approach the vertical asymptote but never really touching it as it approaches infinity. So, rough sketch of the graph will be something like this. What's the y-intercept? Yes, we do have a y-intercept. The y-intercept is at 2. X is 0, y is 2. So the graph crosses the y-intercept at 2. Alright, so our graph will look like this. Look something like this. Infinity, minus infinity, to infinity, minus infinity. And the domain will be minus infinity, one union one to infinity, and the range would be from minus infinity minus infinity minus infinity all the way to, well, y is equals to x right there, that is 0 0 union 0 to infinity. That's it for this video. This is how a rough sketch of the function g of x equals to x squared minus x minus 2 over x minus 1 will look like.